Hello, 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 everybody. I hope you're all doing well and you're ready for more of our Alberta math contest from 2017. We got question number 5 here. What have we got? How many pairs, n, p, are there? N is a positive integer, p is a prime number, and n plus p over n is a square of a positive integer. Oh, square of a positive integer, but p is prime. So this is suspicious. So n and p over n, this has got to be equal to a square. Well, squares of a positive integer are integers. N is an integer. And so we can work out that p over n is an integer. And so n needs to divide p. All right, but then either p is prime, right? So either n is 1 or p. And this really narrows down what we've got. If n is 1, we're looking at 1 plus p over 1, which is just 1 plus p, is a perfect square. How many primes are 1 less than a perfect square? Okay, we might give that some thought, might try and think about that. And the other equation we'll get p plus p over p is a perfect square, except that's p plus 1. So either way, it's p plus 1. So how many primes are 1 less than a perfect square? And that's what we're being asked. Okay. So it's sort of a sneakier question. I can think p equals 3 right off the top of my head certainly works. Are there others? We can make a little chart and try and work some out. You know, I know perfect squares 1, 4, 9, 16, 25. And if you subtract 1, do you get a prime? No. Yes. No. 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 And so you might start to wonder, can I ever get, well, if k is odd, k squared is odd, right? If the thing I'm squaring is odd, then k squared is odd. And so k squared minus 1 is even, and so not a prime. I mean, it's conceivable that k squared minus 1 would have to be 2, but then k squared would be 3, and that certainly is not a perfect square. Okay? So k can't be odd. Could k be even? Okay? Maybe write k is 2 times some number m. Well, then k squared is 4 times m squared. Right? But then k squared minus 1. Oh, I'm silly. No, this is a lot easier to work on. Here, I thought we'd have to do cases just because that's what stuck out at me. But it's so much easier than that. Let's get rid of all this work. So I can just rearrange this. P is k squared minus 1, but this factors. So k minus 1 is a factor of p. K plus 1 is a factor of p. Okay? Now one of these is bigger, one of these is smaller, but because p is a prime, we can see, all right, k minus 1 needs to be 1, and k plus 1 needs to be p. That's the only way this is going to work. So then k has to be 2, and from there, p has to be equal to 3. That's going to be the only possibility. So the one that we sort of spied or could work out by chart, turns out that is going to be the only one, using a difference of squares factoring technique. So there's only one possible pair. Oh, no, hold on. So if n is 1, p is 3, or if n is 3 and p is 3, both of those should work. So there's technically 2 pairs. Just because there's only one prime doesn't mean there are 2 pairs. So 1 plus 3 over 1 is 4. But 3 plus 3 over 3 is also 4. Got to be careful with that. Otherwise, we would have circled B when, in fact, the answer is C. Oh, tricky. Gotta read the questions carefully. And we'll continue to read the questions carefully as we take a look at question 6 next time.